Hello guys, welcome back to my online tutorials. In this video, we are going to walk through the major differences between Mongo and SQL. Thank you all who made the request to create a deep diving video into Mongo. So most of the viewers, they commented in the section, since I am using more Mongo in my recent tutorials, they asked me to provide more information, more knowledge, and more tutorials on Mongo. Thank you all who made the comment and who is following me. Thank you so much. And this video is dedicated for you. So keep doing, keep watching, and let me know. I definitely take the viewers' input, and whenever get time, I'll try to make the videos. So as I mentioned, all my videos are based on real-time scenarios, um, hands-on experience. I explore the stuff, whatever I have done in my development. I'll try to make the videos with the real-time scenarios and real-time implementations. So let's watch the entire video. So who are the target audience for this uh, series or video? So this video mainly focuses on Mongo versus SQL. So the developers who are migrating from Mongo, so the experienced developers who are migrating from SQL to Mongo, they can watch not only Mongo, like all the NoSQL databases, and who is learning Mongo from the beginning. The new developers who started learning Mongo, they can watch it and develop high volume data applications. The applications which is dealing with high volume of data, uh, the developers, they can watch this video, and who is interested in more data science, they can also watch this video. I myself migrated from SQL to Mongo, so I spent significant amount of time in SQL development, various SQL structures, and I migrated to Mongo a few years back. So when I was new to Mongo, I faced a lot of confusions, a lot of issues, and also, yeah, in this video, I'm going to cover all those initial hiccups and the industry comparisons, and also in interviews, if you are facing an interview towards Mongo, like what might be the best candidates for the questions. So I'm going to incorporate all that experience and all that explorers in this single video. So let's deep dive into the video. So if you are a SQL developer and you are migrating to Mongo, the biggest um, confusion is, as a SQL developer, you think everything in terms of tables, but in Mongo, you have to think as documents. So here, um, if you are developing a SQL, the SQL mindset will be a customer table and a order table will be there. This customer table and order table, both are different tables, and they will be referenced by using primary and foreign key. But in Mongo, you no need to create two different tables. In SQL, if you create two different tables, that is a optimized solution. You can use the joins and you can get the data. But in Mongo, this is called document. So you can create the documents and you can create the nodes. So here it's a complete customer document which contains customer information and the list of orders. So here in SQL, you will insert one record here and you will insert multiple records into this orders table. But here you will have the complete document. And if there is one more order, you will add one more node, order ID 110 and amount 250. Next, if there is another order, order ID 12002 and amount is to have 500. And if you have another order, you will have one more node. And not only orders, you can have the payment information, everything you can have within the document. So if In SQL, if you keep in two different tables, it is an optimized solution and you can write the joins and pick the data. But here, if you keep within the same document, it is easy to bring the data. As a SQL developer, when I migrated on my initial days from SQL to Mongo, I was thinking over using the joins. So in SQL, using joins is very common and very optimistic solution. But in Mongo, if you use the joins, it will kill your application. So here, Mongo does support joins, but it support by using the lookup. But they are generally more expensive and should not be primary design strategy. In SQL, using joins is a primary design, but in Mongo, it's not primary. There are different ways to do that. Um, it still support joins via lookups, but the Mongo, if you are using joins, it's really expensive. So the common mistake as a SQL developer when you are migrating to Mongo, you do is building a highly normalized schema that requires frequent lookup operations. In SQL, since you are doing this, you will try to do the same in Mongo, but Mongo best practices suggest store data together if it is frequently accessed together. So as I mentioned, even in the previous slide, so the Mongo and SQL, they are both different in terms of joins. Schema flexibility. This is one more area like where the SQL developers and the Mongo developers get confusion. SQL enforces a fixed schema. So if you want to uh, um, add few more columns to your um, data, you have to go to SQL first and you have to add the columns, then come back and insert the data or update the data. But in uh, Mongo, you no need to define any schema. So like this, the create table, customer ID, name, this will create SQL database with two columns. And if you want to add more columns, you have to come here and update this script. But in Mongo, so when you insert data with this document, it will allow. And for the same collection, if you add one more ID, like one more column with phone number, still it allows. So you no need to change anything with perspective to schema. So here the challenge, SQL developers often worry about inconsistent data. So as a SQL developer, you might think this is inconsistent data, but this is the way the Mongo works. This is the best approach. Put together all your components, put together all your data points and insert in one document so that it can be retrieved faster. So this so in order to that's why when you're working for Mongo applications, you have to validate your data, and you have to do validation at application level, also at schema level. That will make sure your Mongo document is clean. So the schema flexibility is one more major difference between SQL and your MongoDB. Indexes. Yes, both SQL and Mongo has indexes, but they are in different way. So SQL developers often assume indexes work the same way. So in we have clustered index, non-clustered index, two types of indexes in SQL, but the way the indexes work in SQL, the way the indexes work in Mongo, they're completely different. Not only Mongo, in all the NoSQL databases. So there are different types of Mongo indexes like compound index, multi-key index, text indexes, geospatial indexes, wildcard indexes. So this is one of the examples. So you can create like compound index by using customer ID order date. So this will make your document unique. Um, so here in NoSQL or in SQL also, the indexes plays a major role. Like poorly designed indexes can make queries slower, and in case of Mongo, they will um, uh, bear you more expensive. So in the future videos, I'll make specific videos on how to create different types of indexes. But these are the indexes you can create in MongoDB. But in SQL, we have cluster and non-cluster indexes. Aggregation pipeline is one more um, major chunk of your Mongo. So in SQL, you write queries, you will write stored procedures. So I think I treat aggregation pipeline is a kind of stored procedure, but it's not. So in SQL, you will write queries like this, select the column list and this one. But in Mongo, you will define the aggregation pipeline. So this aggregation pipeline is a simple and a small aggregation pipeline here, but I created and I dealt with aggregation pipelines which are more complex and which will allow you to write more complex queries. So I'll show how this aggregation pipeline works in a different video. But so here, aggregation pipelines, especially when you're migrating yourself from SQL to Mongo, the syntax of these aggregation pipelines a bit different than your SQL queries, and you feel this is a complete new programming language or a new entity. But yeah, still you can develop aggregation pipelines, and your SQL experience will help you understand aggregation pipelines slowly. So the thing is, like, if you are working on MongoDB, aggregation using aggregation pipeline is a common thing. Um, so just focus on aggregation pipeline so that you can learn easily. So embedding and referencing. So in SQL, you will refer two tables by using foreign key and primary key. But here in MongoDB, we'll call it as a embedding. So here, if you see like embedded like ID, name, address. So you are embedding address details into your Mongo document. But in SQL, what will happen? You will give the ID, name, and address IDs. So here you are directly embedding the data addresses, but here you will create a different table for address, and those address IDs or address ID you will store it here. So there is a lot different in like combining the data, embedding the data, and referencing the data. So as a SQL developer, you will get confused, but no need to confuse. Like in SQL, you will have multiple tables and you will connect those tables by using referential integrity. In Mongo, you will embed those documents within the main or the primary document. So here SQL developers usually choose referencing because it resembles the foreign keys. In Mongo, developer often choose embedding with data which is read together. So here also there is a debate like what data you will embed and what data you will use it in a different collection. So the data which is being read always together or together, you have to keep it in the same document. You have to embed in the same document. No foreign key constraints in Mongo. So in SQL, you will have the foreign key constraints. That foreign key constraints will let you store the data if the foreign key constraint enforced and if you are not providing data. Suppose if you are trying to insert a data into child table in SQL without having reference of parent data, then it will not let you insert the data. But in Mongo, you don't have that foreign key constraints. Like MongoDB has no built-in foreign key enforcement. So here, the biggest challenge when you're migrating from SQL to Mongo, so data integrity must be maintained by application code, transactions, and validation logic. So you have to, that's why you have to enforce a lot of validation logic in your MongoDB, where in SQL you don't have that much. You don't need that much of validation logic. Query performance expectations. So when you are using MongoDB, usually you will go with high volume data. If your application is dealing with huge volume of data, then only you go for Mongo. Otherwise, you will go for SQL. So that's why performance is one of the major factor in your MongoDB applications. So like the SQL developer often write queries like this. There are certain rules like you have to use joins, you have to use star, instead of star you have to use the individual keys, but here the equivalent Mongo pattern can bypass indexes if not written carefully, like so order greater than. So this is the aggregation pipeline. So order date, if it is greater than this date and less than this date. So here the thing is like how you write the queries in Mongo and SQL completely different. So in SQL, you will use indexes, you will define the indexes, and for the better query performance, you will write things like this. But in Mongo, you don't do that. In Mongo, you completely write things in a different way. So in SQL, we use transactions. So if you're trying to insert data into multiple tables at the same time, you will enforce transactions so that all are get inserted or none are get inserted. So SQL developer rely heavily on ACID transactions, but in Mongo supports multi-document transactions, but they are generally used differently. So here, the Mongo philosophy is design documents to minimize the need for transactions. So, uh, like if you're um, defining a Mongo with the different collections put together, instead of doing that, um, try to put that in a single document. So the transactions uh, will not work in the same way as the SQL in the Mongo. So the things will be a little different here. So this is one more like critical when you are dealing with when you're dealing with Mongo. So you can write select star from orders table um, in SQL. It may not give a performance issue, or it may not run into issues when you have used data. But the same thing will not work with Mongo when the collection has more than 100 million documents. So the number here, it's very common in Mongo. So usually you go for Mongo when you have huge volume of data. So the SQL and the Mongo will deal with large chunks of data, the real-time data. So if you try to, so the db.orders.find is the equivalent query for this in Mongo. But when you run this query in the aggregation pipeline, uh, in the Mongo, which has 100 million, more than 100 million documents, then definitely it will give an issue. So that's why the pagination, projection, aggregation optimization, index first design, these are very important and crucial in your Mongo design and definition and implementation. So in my next videos, when I define the aggregation pipeline, all these things we will define in the aggregation pipeline. So I'll clearly explain how a aggregation pipeline works in the real time. So Basin is one more new thing in like MongoDB. So Mongo stores data as JSON document rather JSON. So we all know JSON, like Angular developers, React developers, even .NET Core developers. But uh, JSON is a advanced on top of JSON. The JSON will be constructed. So the Mongo in the background inbuilt, they store data in the format of JSON. The JSON looks like a JSON, but it's a advanced format than the JSON. So like ID equal to object ID. So types included. There are different types of um, uh, types in the JSON. Like object ID is the one of the data type, date, decimal 128, binary, array, embedded document. So when you try to add a document to JSON, you will embed it, and object ID will hold the object ID for the document, and the date format decimal 128. When you are dealing with decimals, you have to convert that into decimal. Binary data, you can store binary data into JSON, and you can store array of elements, and you can store embedded documents. So SQL developers often initially treat everything as string. So but as a SQL developer, you have an assumption that everything is string, but you have these are the different types of types in JSON document. So distributed design is one of the major um, factor in Mongo. So Mongo by default it support distributed design. So traditional SQL developers may come from a single server, maybe multiple servers uh, as a backup servers. But here in Mongo, we do have few things like replica set. So by default, the Mongo supports replica, creating multiple records in multiple servers and availability. So sharding is one more, and chunk balancing. When you're having multiple records or multiple servers, balancing those chunk of data, and read preferences. So what is your primary? What is your secondary? So all these things, these are the new concepts if you're migrating from SQL. But these will make a successful large-scale performance-oriented application. So in Mongo, if you are seeing replica shading and chunk balancing, read preferences, don't get surprised. Those are the minimum requirements. So I'm going to discuss them in the future videos clearly and in detail. So there are few things which completely new from SQL to Mongo. So different types of indexes you have in um, Mongo, and JSON document is completely new to Mongo. You don't have anything JSON in SQL, and replica set. So that will and aggregation pipeline is a new thing. So if you concentrate on these things, you can easily migrate from SQL to Mongo. And also the tools as a SQL Server developer, you might be using SSMS, SQL Server Management Studio. But in for Mongo, there are a lot of client-side tools like Studio 3T, which is my favorite tool, and Compass is one more tool. And Visual Studio Code also has a extension. If you use that extension, you can load Mongo data. And if you are using Visual Studio Code to understand and to query Mongo data, you can use GitHub Copilot to do some AI generated code and some AI assistance. So yeah, these tools I'll explore in my future videos. Yeah, that's all in this video. Hey, thanks again for watching my videos and giving the feedback and requesting the new concepts. Similarly, if you have any like topics, please let me know. I'll make some time and I'll try to make the video on those topics. I think you're doing. I think you are enjoying my videos and you're learning. And I am excited more about my future videos where I'll discuss more advanced concepts about Studio 3T, MongoDB, aggregation pipelines, replica set, etc. So sit tight and watch for my videos. And thank you once again for watching my video. Happy coding.